Welcome back to the Unreal Engine 5 RPG Framework tutorial series. In this video, we'll focus on building the aiming functionality for our bow weapon using the gameplay ability system. I'll guide you through setting up the aiming ability, configuring aim offsets, and using motion matching to smoothly blend animations while aiming. By the end of this tutorial, you'll have a fully functional and responsive aiming system that feels great in both gameplay and animation. Let's get started. First, we need to download the bow aiming animations, since they were not included in the animation bundle we downloaded in the previous tutorial. Go to the Mixamo website and get the standing aim idle animation. Make sure to place it in the same folder as the other bow animations from the previous tutorial. Now, open Blender. We need to fix the bow animations again. This time, we do not want to transfer any motion to the root bone. To do this, open the advanced options and disable all three axes. Additionally, disable the transfer rotation option. Once this is done, go back to the Unreal Editor. Navigate to the folder where you imported the original bow animations. Here, we need to replace two animations because they contain unwanted root movement. These animations are bow standing over draw and bow standing draw arrow. If you inspect them, you'll notice some root movement causing the animation to slightly shake. This is why we exported the animations again with root bone movement disabled. Let's delete these two original animations. Now go to the folder where you exported the updated versions without root movement. Find the overdraw and draw arrow animations, as well as the aim idle animation we downloaded separately, and import them into Unreal Engine. As before, you can add the bow prefix to these newly imported animations for easier identification. Additionally, I recommend adding a V2 suffix to the overdraw and draw arrow animations to clearly mark them as the updated versions. Next, let's retarget these three animations to the Fortnite mannequin, following the same steps we used earlier. Once retargeting is complete, go to the folder containing the retarget animations. Create a new folder for the aim idle animation and move the new aim idle animation into it. Also, make sure to delete the old versions of the overdraw and draw arrow animations. Finally, find the aim walking animations and enable root motion on them. Be sure to also enable force root lock and set them to looping. For better organization, you can place these animations into a dedicated subfolder as well. Next, we are moving forward with implementing the transition to the aiming state. For the transition animation, we can use the draw arrow animation we fixed earlier. Find this animation and create an anim montage from it. To handle the aiming state, I'm going to define new functions in the Archer interface for handling aim start and aim end separately. To manage the transition to the aim state and handle all archery abilities, we are going to utilize the gameplay ability system. First, create a new gameplay ability for entering the aim state. This ability should be simple, we just need to play the anim montage for drawing an arrow. Also, make sure to assign a unique gameplay tag to this ability, as shown in the video. At the end, the most important configuration for this ability is the ability trigger. We want to activate this ability when a certain gameplay tag is added to the ability system owner, and keep it active as long as this tag is present. When the tag is removed, the ability should end. To grant this ability to the bow's owner, simply set it as the light attack ability in the bow blueprint. Now we need to use the aiming tag to activate this ability when the player wants to aim. We'll implement this logic in the aim start function that we defined in the Archer interface earlier. As in the previous tutorial, I'm going to place all the archery-related events into a dedicated graph. Depending on your preferences, the aim start function can be different, but in most games you'll want to set the character to walking mode and make it strafe. To enable switching to the aiming camera, set the wants to aim variable to true. This should be followed by drawing ranged weapons and adding the aiming tag, which will ensure the aiming ability is activated. The aim end function should reverse these settings. Next, we need to add a new input action that will trigger aiming. I'm going to map this to the right mouse button. Now, go to the player blueprint to implement the aiming functionality. First, I'm going to delete this code in the debug graph that we added in the last tutorial to check bow locomotion. Now I want my player to play bow animations only while aiming. To enter the aim state, we'll call the aim start function when the aim input is started. To exit the aim state, we'll call the aim end function when the aim input is completed. You can now play the game to see what happens. When you press and hold the right mouse button, the character will enter the aiming state by playing the draw arrow animation. Also, you may notice the transition to the aiming camera happens. However, after the draw arrow animation ends, the player ends up in the bow standing idle pose. Let's fix this by playing the bow aiming idle animation when the draw arrow montage finishes. Find the animation and enable root motion with force root lock. Also, set it to loop. We need to play this animation when the character is aiming, so we need to add it to the motion matching system. Duplicate the pose search database that holds idle animations and rename it accordingly. Open it and delete the bow idle animation. Instead, we'll use the bow aim idle animation. Now go to the Motion Matching Data folder and open the bow chooser table. Open the idle state. We need to update this nested chooser to account for more cases. We need separate handling for when the character is rotating in place and when the character is aiming. For in-place rotation, we already have a dedicated Boolean variable in the sandbox character animation blueprint. Let's use this. However, for aiming, we don't have a variable yet. Let's create a new one. Open the sandbox character animation blueprint and find the function update essential values. Add a new pin to the sequence node and save the wants to aim value to a new variable. Name it as aiming. Return to the bow chooser table and bind the asAiming variable to the second column. Now make sure to configure the chooser table as shown in the video. This setup will ensure the aim idle animation is used when the character is aiming. Additionally, this setup allows us to reuse turn-in-place animations from the game animation sample project rather than using turn animations from Mixamo, as those provided by Epic Games are more precise. Let's play the game now and check how the aiming state looks. As you can see, when the equip arrow animation finishes, the player enters the aim state and the aim idle animation is played. However, there are a couple of things we can improve here. We should add aim offsets to ensure the character's upper body follows the aiming direction. Also, we need to fix the turn in place while aiming. Right now, the system exits the aiming animation when turn in place is played. We should prevent this and make sure only the legs turn while the upper body stays in the aiming pose. Let's start by adding aim offsets. First, I'm going to duplicate the bow aim idle animation and place it in the aim offsets folder. You can rename it to follow the naming convention used for other aim offset animations from the game animation sample project. Open the animation you just duplicated. The first thing we need to do is trim the animation to keep only the last frame. You can do this by right-clicking at the end of the animation timeline and selecting the option to remove frame 0 to frame 114. Next, we need to make this animation additive by setting its additive anim type to mesh space. Additionally, set the base pose type to selected animation frame, and choose the bow aim idle animation as the base pose. Now, we need to create aim offsets for all directions. First, I'll start by creating 2 aim offsets that rotate the character's upper body by 90 degrees in both the up and down directions. Start by duplicating the neutral aim offset. For the upward aim offset, find the spine_01 bone and rotate it by 90 degrees upwards. Make sure to lock this pose by clicking the Add Key button. Repeat the same process to create the downward aim offset by rotating the spine_01 bone 90 degrees downwards. Next, we need to create aim offsets for the left and right directions. Finally, you'll also need to create 4 diagonal aim offsets, top left, top right, bottom left, and bottom right, following the same method. Once all aim offsets are ready, we should create a blend space using these new aim offsets. For the skeleton, select the Fortnite skeleton. Configure the horizontal and vertical axes as shown in the video. Place each aim offset in the blend space accordingly. You can test the blend space by moving your mouse over the preview graph while holding the Control key on your keyboard. Next, we need to create a new chooser table that outputs the blend space asset as its result. We are doing this to make the system support different types of ranged weapons, not just the bow. Later on, it will be easy to add other ranged weapons, such as a crossbow. Now, let's use this chooser to dynamically find the correct aim offset that needs to be applied to the original pose when the character is aiming. Go to the Sandbox Character Animation Blueprint and find the anim graph. Locate the part where the head aim offset is added. This is where we'll also add aim offsets for ranged weapons. We'll follow the same principle used for the head offset. This time, for the active value, we'll check if the character is both in ranged combat and aiming. For the false pose, we'll continue using the output from the head aim offset. For the true pose, we'll add a new blend space player. Configure the X and Y coordinates as we did for the previous blend space player, using the function getAOValue. Also, ensure that the call site for both coordinates is set to thread safe. The key difference now is that we won't use a static blend space asset. Instead, we'll set it dynamically. To do this, we need to create a new function for the blend space player on update event. Inside this function, we'll evaluate the aim offsets chooser table and assign its output as the blend space asset for the blend space player node. Finally, connect the output of this blend space player to the dead blend node. However, if you try to compile this blueprint now, you may see some errors. This happens because the blend space must be set as a dynamic value for the blend space player we just added. Once this is configured, everything is ready, and we're ready to test the aim offsets. As you can see, the bow aim offset is now applied correctly, and the upper body follows the camera's aiming direction. However, we still need to fix the in-place rotation while aiming to ensure a smooth and realistic aiming experience. To achieve proper in-place turning while aiming, we need to separate the lower body animations from the upper body. When turning in place during aiming, the leg should play the turn in place animation, while the upper body continues playing the aiming pose. Let's go to the animation blueprint and make space between these two blocks of logic. We'll add this new setup right after the additive lean node. To split the upper and lower body, we'll use the layered blend per bone node. In its settings, make sure to configure the branch filter on the spine_01 bone with a blend depth of 2. For the blend pose, we are going to dynamically inject the aim idle pose using a sequence player. This setup will be similar to how we dynamically selected the ranged weapon aim offset blend space. Again, to keep this system flexible for various ranged weapon types, we need to create a new chooser table. This time, instead of outputting a blend space, the chooser will output an animation sequence. After creating the chooser for ranged weapon aim idle poses, go back to the animation blueprint. Next, implement a new function for the sequence player on update event. Follow the same logic as before, evaluate the chooser table and set its result as the sequence for the sequence player node. Moving forward, we also need to control the blend weight based on whether the character is in ranged combat and is aiming. Finally, make sure to enable Mesh Space Rotation Blend on the Layered Blend per Bone node for smooth blending. Let's test this in the game. As you can see, the character smoothly rotates to match the aiming direction. When the rotation angle is large enough to trigger an in-place turn, the legs play the turn in-place animation, while the upper body remains in the aiming pose. We've successfully applied aim offsets, and the system is dynamic and ready for future extensions. You can also try walking while aiming. In this case, you'll see a blend of bow walking animations with the bow aiming pose applied to the upper body. If you prefer to use the dedicated bow aim walking animations downloaded from Mixamo, you can create a new pose search database for them and update the bow walking states to select these animations when the character is walking and aiming. However, keep in mind that in this setup, only the lower body will play the walking animation, while the upper body stays controlled by the aim idle animation. You may have noticed that the player is smoothly switching between the regular camera and the aiming camera, thanks to the setup we copied from the game animation sample project. However, the current aiming camera position isn't ideal for bow aiming. Let's improve this now. Open the player blueprint and locate the update camera function. I'm going to do some quick refactoring inside this function to keep it clean and organized. Next, you can adjust the aiming camera to suit your game style. For this example, I've found that increasing the socket offset on the Y-axis to 100 works well. You can experiment with these values and play the game to see what works best for your project. There's one more thing we need to fix. The target lock should be unlocked automatically when aiming starts. We can easily handle this by overriding the aim start function from the Archery interface in the player blueprint. Make sure to call the unlock target function first, before continuing with the parent function's implementation. With this, you now have a fully functional and smooth transition between melee combat and ranged combat. When the player locks onto a target and switches to ranged aiming, the target will be unlocked, allowing the camera direction to control the character's upper body. Also, the camera style will transition smoothly between the combat camera and the aiming camera. Finally, let's add a simple crosshair widget to assist with aiming. Start by creating a new user widget blueprint. Since I don't have custom artwork for the crosshair, I'll use basic white images to design it. Once the Crosshair widget is complete, open the RPG HUD interface and define a new function to toggle the Crosshair widget. Next, go to the RPG HUD widget and add the crosshair to the center of the screen. Set its visibility to collapsed by default. After that, open the RPG HUD blueprint and implement the toggle crosshair widget function. Lastly, return to the player blueprint. When aiming starts, show the crosshair widget. When aiming ends, hide it again. Let's do a final test and see how everything works together. As you can see, the camera transitions are smooth, the target unlocks properly when aiming, and the crosshair appears to help with accurate targeting, just as we intended. That's all for this part of the tutorial. We've successfully set up aim offsets and smooth transitions between melee and ranged combat. Next time we will implement firing an arrow. If you found this video helpful, please consider giving it a like and subscribing to the channel so you won't miss upcoming episodes in this series. Also, check the video description for useful links, including project files. Special thanks to my Patreon supporters. Thanks for watching and see you in the next tutorial.